So the last day of the 12 days of OpenAI announcements, and we're here. Hello, Kamel. Good to see you. I still have the stream on pause. I wanted to make sure I can set up my laptop as well and make sure we are doing everything in time. Like, you know, when we do it, it's properly set up. So we're gonna get going right in a minute. I also wanted to give people time to tune in. So, and also let's check the audio. So Kamel, you can hear me, I assume. So can you just give me a feedback on whether you can hear me? And I'm gonna also quickly start the audio of the video and let's see if you can hear that as well. Can you hear this? It's a little background music. All right, guys, audio check. Can you guys see everything? Should be good. 10 out of 10. Let's go. Okay, hold on. There we go. That's the stream. And I'm gonna fast forward a little bit. So. Oh, Sam is here. Oh my God, spoiler alert.
Good morning.
Okay, hold on. From here. Let's go.
Good morning. We have an exciting one for you today. We started this 12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, o3 and o3-mini. O3 is a very, very smart model. o3-mini is an incredibly smart model, but still, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. We've got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So
I'm really excited.
Mark. I lead research at OpenAI. And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding
put myself here.
If you could bring those up. So on software style benchmarks, we have SweetBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this contest coding site called Codeforce is about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Oh, wow.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once on this, so I'm safe. But yeah, really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to test.
These are extremely hard.
Yeah, very, very hard problems. Even Terence Talas says, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Camrad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC-AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC-AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC-AGI is. So I would love to show you an example here. ARC-AGI is all about having input examples and output examples.
Well, they're good.
They're good? OK. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
OK, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it. And that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC-AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC-AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC-AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC-AGI Pub. So congratulations to that.
Thank you so much. Yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. this is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this, or any model that has done this beforehand. So this is new territory in the ARC-AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But the work also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ARC-AGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know, it's also a benchmark that we've been targeting and been on our mind for a very long time. So excited to work with you in the future.
Worth mentioning that we didn't. We target and we think it's an awesome benchmark.
Yeah.
We didn't go do specific
do
work for
specific
this. This is
things,
just
yes,
you know the general O3. But yeah, really appreciate the partnership. And this was a fun one to do.
Absolutely. And even though this has done so well, ARC-Prize will continue in 2025, and anybody can find out more at arcprize.org.
Great. Thank you so much for coming on.
Absolutely.
Okay, so next up we're going to talk about o3-mini. o3-mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey.
Hey,
How are you?
Hey.
Hi, everyone. I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released o1-mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about o3-mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for o3-mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of o3-mini. So on the left-hand side, we show the coding evals. So it's like code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, o3-mini is able to have increasing ELO, all outperforming o1-mini. And with median thinking time, it's able to measure even better than o1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's the o3-mini high is still a couple hundred points away from Mark, it's not far. That's better than me, probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that o3-mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, compared with better performance than O1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On o3-mini.
Live demo. Yeah.
So, and hopefully you can test out all the 3 different low, medium, high thinking time of the model. So let me paste the prompt.
Oh, this is ChatGPT Alpha.
So I'm testing out o3-mini
on the top
high
left.
first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this Python script, it will launch a server and locally with a UI that contains a text box. And then we can make coding requests in a text box it will send the request to call o3-mini API, and o3-mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right?
Hold on. I want to read the prompt again, what they sent. So write me a Python script which launches a server locally for an HTML file which has a big text box. When I enter text into that box and press submit, it should send that request for code to OpenAI o3-mini API with medium reasoning effort. Take the resulting code, save it to a temporary file on the desktop, then execute that file in a new Python terminal. Few more details. It can find my API key in /API key. Please add some extra prompting into the request to the API to specify that it should only return raw code without any formatting or markdown at all. You'll be executing on a Mac laptop. Okay.
Run this like Python script with a make o3-mini API, and o3-mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. we have a UI where we can enter some coding prompts. Let's try out a simple one, like train OpenAI and a random number. Submit. So it's sending the request to o3-mini medium, so it should be pretty fast, right? So on this
41.
terminal, yeah, 41. That's the magic number, right? So it saves the generated code to this like local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI.
Hold on. Okay. So generate a code that evaluates o3-mini with low reasoning effort on GPQA dataset. You need to download the raw file in OpenAI public blah blah blah. The question is in question. The 4 options are incorrect answers. Incorrect answer 1, incorrect answer 2, and 3. For each multiple choice question, shuffle the options, give format instructions. Please output answer, letter, whatever in the last line. And use a regex to grade whether the model output is correct or not. Make all tasks async for maximal parallelism and robust against failed API calls. Add a 30-second timeout if you don't get a response from API call and retry for 4 times. Print progress using TQDM. Print the accuracy at the end. If you need a reminder how to use the OpenAI API, look at this example. And I guess that's just the rest of the code.
So in this task, we asked the model to evaluate o3-mini with the low reasoning effort on this hard GPQA dataset. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the o3-mini with low reasoning effort. Yeah, let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go, go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Okay.
It's 61.62%, right?
Amazing.
62%,
Jesus.
right? With a low reasoning effort model, it's actually pretty fast. Then full evaluation in a minute. And
somehow very cool to like just ask a model to evaluate itself like
yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 data set, o3-mini low achieves comparable performance with o1-mini, and o3-mini medium achieves like comparable better performance than o1 if we check the solid bar, which are pass of ones. And we can further push the performance with o3-mini high, right? And on the
I'm gonna move my head a little bit so you guys can see this.
right-hand side plot, when we measure the latency on this like anonymized O1 preview traffic, we show that o3-mini low drastically reduced the latency of o1-mini, right? Almost like achieving comparable latency.
Okay, so what we need to look at here is like o1-mini is comparable to o3-mini with low reasoning effort. So you can see in the competition math scores. And then o3-mini with medium competes with o1 in the reasoning. But the latency is a lot less. So o1-mini with o3-mini low is like 3.8 seconds versus 0.99. So it's faster there, and o1 is slower than o3-mini with medium. So that's what we need to look at.
The latency of o1-mini, right? Almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And o3-mini median is like half the latency of o1. And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on o-mini series models. And here, o3-mini will support all these features, same as o1. And notably, it achieves like comparable better performance than for O on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means that is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right? Next time, we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah, so with that, that's it for o3-mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah, thank you
really
so much.
great work on
Yeah,
you.
thank you.
Cool. So I know you're excited to get this in your own hands. And we're working very hard to post-train this model to do some safety interventions on top of the model. And we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with o3-mini, and also eventually with o3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. Great. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it'll just uncover that, hey, this user's trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over-refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically, you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both at the same time.
Yeah, it is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage safety to get, leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah. Fantastic.
OK, so to sum this up, o3-mini and o3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch o3-mini around the end of January and full o3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas.
Merry Christmas. Oh my God. Jesus fucking Christ. What was this? Oh my God. So we have O3. And people in the chat pointed out really well that it's not O2 because O2 is like a UK telecommunication company. So they would be having a lot of fights with it. Now, this is big announcement. So let's go back and let's review these things. So obviously we cannot try it now. It seems like it's gonna be available for public testing for a few select organizations or like safety researchers. I will definitely apply, but I'm gonna ask around for a couple of organizations if they can like support me with joining, so it can be maybe have better chances to join. But I'll see. If you know someone who is like in the cybersecurity and could endorse me to join the O3 safety testing, that would be amazing. So a lot of really important scores here. Now, I don't know much about the coding and software engineering bench scores, but in comparison to O1, this already tells like how much better that is. And we can see competition code. They didn't explain what the blue bars are with the different color. So I just kind of assume this is like the low and the high reasoning effort in between the two. And then, what they said is that the researcher in the middle, I forgot his name. Maybe I should do more research on knowing these people's names, but he has a 2500 score. Okay, so O3 already, and he's a software engineer and competitive coding coach. Okay, and O3, oops, not this one, this graph. O3 has already overperformed him, and then the best person at OpenAI at competition coding has somewhere around 3,000, and they jokingly said like, oh, he has a couple more months to be the best, and then O3 will take that out. So now this is the important part, I think, because here 100 is like no mistakes, okay? And here again, 100 on the GPQA is like, it's perfect, no mistakes made. Humans at GPQA Diamond with experts in the field score somewhere around 70. So O1 already outperforms humans on these things, and O3 even more. Fuck. Okay. Now this one is also really interesting. Research math, Epoch AI frontier math. And then SOTA stands for like state of the art. So the previous state of the art was 2.0, and now O3 has 25 accuracy. So there is a lot more improvement here, and they didn't talk anything about how they trained the model. but it seems like that, and then other people also talked about this, is that how good these models are when trained on synthetic data instead of real human generated data. It seems like they can be trained on synthetic data. And OpenAI, oh wow, 55 viewers watching now. Hello everybody, welcome to the show. So it seems like that with O3, they're probably training it on a lot of synthetic data, and OpenAI, what's important here is that this is the things that they announce. The IP that they have about training these reasoning models is probably way ahead of everybody else. Like they have all the brains that they need to be able to train these models. And I think they are generating a lot of high quality synthetic data, and they have, like a lot of tests on which kind of approach is best. And it seems like that AI model improvement is not going to slow down just because we kind of run out of data. So it's they can be trained sufficiently well on synthetic data more efficiently, and so the models can be smaller, which means they are cheaper and faster to run, consume less electricity, which is very important from an environmental perspective and also from the cost perspective. And so these models will get, relatively speaking, smaller and smaller because they can be trained on a lot higher quality data. So I'm really curious to see where this is going to go, but it seems like we are reaching some kind of saturation, but that's on the scores, or not this one, the GPQA one, on the competition math. Where is it? Hold on, sorry guys. Yeah, this is the GPQA. Yeah, so competition math and PhD GPQA Diamond. The 100, we see saturation because the saturation is like it's by default built into the tool, okay, or the testing. But on other platforms like the competition code and this research math and so on, again, accuracy 100, there's like a lot of improvement here for these models. Okay, this IQ, or like this test is very interesting. I don't know much about it, and we can read a little bit about AGI and what ARC-AGI is doing. I also loaded up the ARC prize here to see what they're doing and what exactly this is, because this is the first time that I'm hearing about it. Now, I'm not an AGI researcher. I just teach people how to use AI, so that wasn't really on my plate. But this thing is also very interesting. Let me just move my head outside here. Yeah, so you see the test output is empty, okay? So, and they said that almost no AI can actually do this. So it seems like the example one input is this, and then the output is this thing. So you need to create the border, and it has to be the same color as the dots, and it has to be the width to how many dots are in there inside the square. So you see this is like 2 red means a 2 wide red border around. This has 3 blue, so it's a 3 wide blue border around. This is a 1 green, and then this is a 3 wide red. And this is a 4 wide light blue, and this is a 1 wide blue. All right, so the test out input is this, and then obviously we humans could figure this out, but this is a very difficult problem for AI to do. They also talked about like the O family performance on ARC-AGI, the semi-private eval, and when they gave it like a lot of compute, it scored 87.5%. Now I don't know what 100% is. I don't think that 100% is AGI, but we are getting into the territory where these models will significantly outperform humans on every single thing. I love the enthusiasm from this guy demonstrating o3-mini. That was amazing. So yeah, okay, let's talk about that demo. I just kind of lost my shit there. Okay, so Tyler asks, let me answer that real quick. So what will this mean for humanoid robots in your opinion? For humanoid robots, this means that they will be able to make decisions better with less errors based on what they should be doing. And the important thing, because with humanoid robots, I think the first thing that comes to mind with many people is that, oh, is this gonna kill me or something? And then to that, we have the answer here on this graph, which means that the models O1 and O1 preview in green here on the right side of the graph, as you are to the right, it means it rejects the requests. And there's the I would need to do more research on what this chart actually means, but there's the over-refusal accuracy. So how much stuff it actually refuses that I think that it should or shouldn't. I don't know exactly. But what this means is that the reasoning models, O1 and O1 preview, actually reject a lot more harmful requests than the other models like Claude 3.5, Gemini 1.5 Pro, and Flash. Hey, tell us how can we try it? We cannot try it yet. We are gonna be able to see that in end of January. Until January 10, you can subscribe to you can apply to be like a public tester for safety. There's probably gonna be like a page on OpenAI's website soon. They showed this application form here at the end. Where, hold on, is it here? Somewhere here. Oh, it was a little bit earlier. I don't know. Yeah, there's how to apply, right? So you will need to submit your application, first name, last name, institutional or organizational affiliation, OpenAI account email address, and country region. Okay, so its application is closed on January 10, and then they said that we can try o3-mini on probably end of January. When I was thinking, my prediction was like, okay, it's coming like mid next year, but it seems like it's gonna be here a lot sooner. So January 30, we don't even need to sleep that many times until we can give it a try. And what we're gonna get is o3-mini first, and then o3 later on. Now, what I wanna go through again is this demo that they did using o3. And let's go through the prompt again, because this was something that is really interesting. And I wanna highlight this. So first, they said, Delphi asked, how big of a gap is this from O1? It's a big gap. I'm gonna come back here. It's in minus 10, 20. It's a big gap. So look at this score, competition math. 100 is like perfect. So you might see that, oh, this is only a 13 point improvement. But this actually means that the O3 makes mistakes 4% of the time, but O1 makes mistakes 17% of the time. So it's actually 4 times as accurate. And then GPQA 87.7, which means it makes a mistake on average on 13% of the questions, whereas O1 makes mistakes 22%. So it's almost twice as good. Okay, so it's a huge gap in terms of O1 and O3. Okay, let's go back, minus 10, 20. And feel free to ask questions in the chat. I see a lot of people found this live stream right now, so it's good to have you guys here. We're gonna be talking about this for like at least another hour or so. So feel free to ask me anything, and we can just get the conversation going. So what they demonstrated is that they asked O3 to write a Python script which launches a server locally in the guy's laptop for an HTML file which has a big text box. When I enter text into that box and press submit, it should send that request for code to the OpenAI o3-mini API, which means O3 is supposed to be able to write valid API requests. Okay, so that is a big sign towards agentic function. Because the biggest problem with all the AI language models is that they cannot configure the agentic, they cannot configure the API requests themselves because they are not fully trained on them. The documentation is not that clear, and they would get errors, and then now they're not autonomous anymore. So what this is it's very important that it can write an API request, a valid API request for the app to also send a request to o3-mini with medium reasoning, and take the resulting code. So whatever it gets back from whatever it gets back from that text box, takes the resulting code and saves it into a file and runs it in the computer in a new Python terminal. And it also has the API key, and it also has some extra prompts to make sure it runs well, and make sure you know that you're on a Mac laptop. Okay, and now it writes this code. So Python script wrote it in 38 seconds, and then so what happens here is they go into,
So we should
you know, they manually launch it the first time, this Python file, and then this is where it's hosting it. Right, so the guy will open it in the browser.
We're launching something.
Okay, so there we have it open. So this entire site was generated by AI. And when you hit the submit button, it's gonna send an API request to O3 to do something. Okay, so in this case,
we have
they will ask like print OpenAI and the random number. Right? He clicks submit. Boom, the request is now sent to o3-mini with Medium to process this request and write some code about it that can do print OpenAI and a random number on the guy's Mac computer. And a couple of seconds later, we already have it in the terminal that said that this file, Python 3 users OpenAI desktop temporary whatever, VOP6K Python was launched. And the final response, the print is OpenAI 41. Okay. And then they added something else. Let's see what was the next one. Generate a code that evaluates o3-mini with low reasoning effort on GPQA dataset. Now here's where you can find the dataset, and they basically explained how the dataset works. And then I want to find this part. Hold on.
So now let me copy the code.
No, this one. So if you need a reminder how to use the OpenAI API, look at this sample. Import async IO from OpenAI, import OS async OpenAI, client equals async OpenAI, async dev sample. So here's the code, this is the right code on how you need to write o3-mini requests. So they had to give it to this, example because it was not trained on this. Okay.
You first download the raw file.
So let's see the
and then
timing.
You need to figure out which part is a question, which part is a.
I already started running it. Hold on.
In the
Go back.
code UI.
Paste. I already submitted it. Okay.
So in this task, we asked the model to evaluate o3-mini with the.
So it wrote the entire code that can help evaluate itself. So now this is sent to the O3 API to write the code, export it as a file, and then run it on the computer. And now we have the question, like, you know, the score going here.
All the questions.
So it's already running on the computer.
And then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's
and then just
calling
it gets stuck a little bit.
Show what the request was again.
Mm-hmm.
Oh, it actually returns the results.
Okay.
It's 60.
So it says 61.62% accuracy on the GPQA, and which model was this again? o3-mini with low reasoning. So there this is the competition math. Was it GPQ? Did they show the GPQA benchmark? Yeah, they probably have that somewhere. Hold on. It's competition code. Oh, where are my thumbnails? No, they only showed O3 for GPQA. So o3-mini is actually worse on GPQA than O1 preview and O1, but it's totally fine. Depending on how fast, like that's how fast it took it to go through the questions. I think for us to go through it would be like half an hour. I don't know how long that test is. It's like a bunch of physics, science, like biology, chemistry, and things like that, questions, like science. Okay. Yeah, so I think this is the big one, that it can now write code at a sufficient level to be able to just fully execute it on the computer. And if you combine this with not a normal computer, but like a virtual computer, then that's like a sandbox environment. How code interpreter works right now, this opens up a lot of new opportunities for agentic function, and I think that's the direction that we are going in, and obviously that's the direction we have to be going in. But reliable agentic functions also require the model to be able to have really good reasoning, because it cannot make mistakes on configuring like what to do. Okay. All right, let me see the chat here. Oh my God. Has anyone tried the 2.0 experimental preview model, not Flash from Google? It's really impressive. I have not. I think Camel from the community tried it. So, Camel, can you share a few thoughts on that? Oh, I cannot read the chat now. What's going on? Okay, this is so good. I think Google will release Gemini 2.0 12.06 thinking model next year, not Flash, to stay in limelight. We'll see. Figure robotics partners with OpenAI along with other companies. 2025 is definitely going to be interesting. If we are now expecting 2 to 3 models a year, co-scaling with robotics. Yeah, it's crazy. Well, they released a 2.0 experimental advanced yesterday. It's really good, but I think it doesn't reason like 01. Love how 2025 will be full of completely automated AI agent models. Yeah. O3 will be released in the end of January for public, but we can try it earlier as a safety researcher. What is O2? We're not going to have O2 from like OpenAI, because O2 is a UK telecommunication company and it's like trademarked. So that's why they probably skipped it. Okay. I hope everybody understands the power of this demo that we saw with O3 writing the code, writing code that can write code. Like that's what happened. Oh, Camel's driving. Okay, but Camel tested it out. It's good. So that's the kind of thing that we need, because if you look at if you think about it, going back to this is actually the request here. Every single thing that you do now digitally in your work, or not every single one of them, but most of them probably have an API request that can do that for you. Like you can create a new Google document through API. You can create a new spreadsheet. You can listen to what changes in the spreadsheet with API. And all of those is like 10 to 20 lines of code. Okay? So if we have a model that can write that code live when it's making the, I need to update the spreadsheet. Okay, how do I write the code? Boom, code is ready. And it can take action on that. That's like from there on, it can just basically do anything. So then the question is, how well can it write the certain different code? How much was it trained on all kinds of different tools and features? So once it can autonomously configure API calls, that's when we have the autonomous agentic function to do anything. Because right now the biggest problem with creating the agents for any specific use case is that you need to pre-configure the action first before you tell the model that it can take that action. So I don't know if you guys fully understand that. I have a kind of like a mirror board about it. A couple of days ago, we went into the Apple Intelligence, and I showed like how you can create Apple Intelligence for yourself. Now I'll just bring back that mirror board here. Okay. So there we go. So, and this is okay, let's just focus on this top flowchart first. Okay. So what was happening there is, on the iPhone or Mac, it was listening to the microphone input, and text input, files, images, send it to ChatGPT, and then it would just send it back. And we didn't have this arrow. But once ChatGPT can decide which function to call, then it can just do whatever it is supposed to do. Okay, so this is what we call the tool use and function calling. And if I go back to the previous tab, this is what this benchmark is for. Internal function calling, this guy. So GPT-4o is 90% accurate on internal function calling. O1 is at 95, which means 20 times, like 19 times out of 20, it calls the right function to do the next thing. So going back to, how do I do this? No, this one. So O1 decides that, if the task that it receives from a user or any other API is to do a calendar event, then it's gonna correctly call that tool. If the function is to send an email, it's gonna correctly trigger this flow. And so I made this kind of flowchart on how to build your own Apple Intelligence in Make, which is a no-code platform. Is that you have a trigger where you can input your tasks to Make. It can be Slack, WhatsApp, chat tools. Send an email to your AI, could be like AI at certain company. You can send a text message. You can set up a webhook, whatever. Some way you need to input your data. What's the prompt it needs to? What does it need to do? This is what they also did with this HTML box, where it's like, okay, write me a code that does this. Okay, so this input, it can be an input box in an HTML file. Okay, and then we have, in this case, we would have a decision agent, which handles the function. Maybe this could be called like a function calling agent, function call agent, or tool use. Maybe tool use is okay, tool use agent, which decides with a one-word response on next function to call. Okay, and then in Make, we can set up a router. And then if this GPT responds with new calendar event, then the top flow will run. If it responds with modify calendar event, then the bottom flow will run. If it decides to create a to-do, then this flow will run. And the more of these you can pre-configure before running this, the more functions your agent is going to have. And then you can build in more logic that once it does this, then it can do some other stuff. And it's like GPTs are talking to each other in a consistent thread. And it can be super complex, okay? So I just wanna make sure to keep things simple. But what we are looking at in the future, and what we are thinking that maybe this will come like at the end of the year or something, end of next year, is that the AI will be able to not just tell what function to call, but also write that function. So write these steps on what we're doing and then execute that. And that is the full autonomous AI agent. So right now, every agent that you might see online cannot do anything. It can only do what it was configured to do. Okay, so that's the big difference. And I think once we have an agent that can do anything, because it can write the code accurately without getting errors. So let me go back here. So coding it to 100% accuracy. So the API call goes through. Maybe it needs to have a big database of API calls. Maybe it needs to be just trained on that. That's when I think we will achieve the AGI that we're all looking for. And then it can reason on what to do there. And that's the kind of direction we're going. And I think this is the important part. That now O3, or in this case it was o3-mini, could use code to write code. Automation inside automation. Yeah, exactly. Cosmic Cells. How do you think they got to O3 from O1? Did they remove O1 to create synthetic? Did they involve O1 to create synthetic data to train it? Any other secret sauce they may have used? Well, they said that O1 is a brand newly trained model specifically for reasoning. And I think what they did is they saw a lot of data on what good and bad reasoning outputs are, and they just generated more of the good outputs synthetically, and then they could do that. I think that's how they did it. Mugiwara Nodeya says the biggest issue is reliability over time. Yeah, so the reason why that's the issue is because until this function calling is very close to 100, then it will, like, it adds up. This mistake will amplify if you keep it running for a while. Me Vance asks, do you think Google can beat OpenAI at this pace? Well, that's very hard to tell. I think OpenAI has a big advantage against Google right now. And again, this comes back to how focused are you? Because Google is like, they have all this shit going on, the Gmail and search and just like all these other stuff. And OpenAI is just focusing on developing AI. So I think that's why Google will not be ahead of OpenAI in the AI development. OpenAI will launch a model, and then later on everybody catches up. Like, I just did a review today in the community about what happened in 2024 and what my predictions are for 2025. And I think one of the things there we saw is that OpenAI announced Sora in February, and then they launched it in December, and it took people like 6 months to kind of like catch up to Sora's level. And then they launched GPT-4o with multimodality, and then a couple of months later, some other people also launched that. I think O3 is a huge jump forward in terms of having this reasoning. I think this reasoning is a big step forward, and I would love to see the reasoning tokens actually, but unfortunately it's redacted. I really want to have a reasoning model like O1 and then be able to see how it thinks itself through the problem. And there was actually an interesting study that I saw somewhere that there are attempts to make models reason without language. So they wouldn't reason with reasoning tokens. They would just use their whatever they do, like just run the electrons through the circuits instead of actually having to output the tokens. Right? So they would just think about the tokens, and then that would change the reasoning. I don't know who did it, and so it's like I'm not entirely on top of my game here in terms of this research, but that was also very interesting. Mugiwara thinks yes, OpenAI will. Well, I can do a poll, guys. So let's start a poll in the chat. So do you think Google can beat, hold on, OpenAI? And it's just a yes, no. I just vote. What happens to the industry if it gets close to 100% on the live bench? Well, to be honest, I don't know what exactly live bench is, so. Oh, hold on. I'm in full screen mode. So live bench includes math, coding, reasoning, language comprehension, instruction following, and data analysis. This changes LLM evaluation by providing frequently updated questions from recent information sources, ensuring automatic scoring based on objective ground truth values, minimizing test set contamination biases. Okay. Top models achieving under 65. Okay, let's see the GitHub. So it's based on reasoning, math, instruction following, data analysis, coding language. Okay, it's like how do you install? Okay. So then 100, I assume, would mean that it does not make mistakes in reasoning, math, instruction following, data analysis, coding, and language, which by definition would mean that it is better than humans, because we know that humans make mistakes. So by definition, then that would mean that it's better than humans. So that could be the first super intelligence as well. But it's more like an AGI function. What subscription will O3 require? We don't know yet. I assume it's gonna be at least the Plus for sure, with limited use, just like with O1. And then for Pro, it's probably gonna be like more compute. Okay, let's see the poll. Hold on, why does it not show? Oh, so it's based on 25 votes, 60% towards OpenAI, 62%. So there's your answer. That's what the public thinks. Mugiwara no Dishi says Google will win because they are using games and the model that creates games, as well as the model that can play any game. Mastering novelty is key to AGI. Game words are the best test environment. Okay, that's a fair point. However, here's another argument. Writing code for API requests is the real world version of putting your staff in the storage or buying potions from the NPC. So API requests, it's also a digital environment where they can interact with the world. And it's a real world, and it creates them real world use cases. FX Tourist. I remember when people were panicking that the wall will start another AI winter law, but forgot that O-Series bypassed the wall effects for a long time already. Yeah. We thought we hit a wall because there was like nothing could surpass GPT 4.0, because people other than OpenAI were thinking about the normal chatbot use. And then OpenAI said, no guys, let's do the next step. Chatbots are good enough, let's do reasoning. Yeah. All right, let's do another poll. This is fun. My next question is, do you think O3 will be available on the $20 per month plus plan? All right, let's see what you guys think about that. And while you do that, I'm gonna switch off my camera for 1 second. I need to grab some water because my mouth is like so dry. So give me 1 second. All right, there we go. By the way, I just left it on the kitchen counter. Okay, so here's what people are saying. Available, yes, but very limited. They want to give normies a taste. Yeah, of course they do. I think the plan will change. Santiago, how do you think the plan will change? Is it like, are they gonna like increase the price? There are rumors that they're probably gonna increase the Plus subscription to $30 to $40 a month. But I think then they should definitely release like a $5 to $10 plan that only has access to like 4.0 to give people more, accessibility use. More limited until like a certain cap base or something like that, but let people use it. Yeah, it's possible that maybe o3-mini is gonna be the one on a plus plan, and then o3 will only be on the pro subscription. Or maybe you can use it for like, I don't know, 10 times a week or something like that. Mukibara says, good point, but you are still limited to the API requests and structure. In the game, you have base rules, and then you can have unlimited ways to express or build off that. Well, depends on what you mean, unlimited. Because if I think of like an MMORPG like World of Warcraft, there are a lot of ways you can put together a build, but it's not unlimited. And there are actually the best builds that you kind of need to make sure that they are balanced. We'll see. I agree with the games being a really, really good case for testing. And we'll see how OpenAI or how Google can pull that off. It's this is what I love about this. Competition happening right in front of us, right? This Cinebench, or what is not Cinebench, that's for cinematic benchmark, live bench. And then we just get the benefit of it because everybody's like, I want to beat you. I need more users, so I make a better model. And then we are just here reaping the benefits. This is what I love. It's amazing. So it's good to see Google going in the direction of games, which is how OpenAI also started. I don't know if you guys remember OpenAI beating 1v1 Dota players and then 5v5 Dota players as well, with models trained entirely by just playing the game. So that's probably gonna be like that also signals that, yeah, games are a really good use case. And yeah, we'll see what happens. Let me just go back to, go back to my face. Okay, let's see what you guys say. $2,000. Well, probably not. Hope so. Hope not. Camel says, I have to go. See you soon. Yeah, see you, Camel. Probably just limited use is like 01. Yeah, we need to master both API requests and virtual words. Yeah, for sure. o3 will be available on 200 tier with limitations, Jamie thinks. I don't think for a 200 plan it's going to be limited though. I don't know. We'll see. Most people don't even need o3 levels of intelligence. Yeah, that's true. Most people don't even need o1 level. They will increase the plan for an AGI-like workspace, and they will invite people to have... Hold on. So about what you just said about the AGI-like workspace. So let's go back here. Remember how when it wrote the prompt, when they sent the prompt this to GPT, says it can find my API key in API key, right? So here's what I think will happen. And I'm just gonna take a screenshot of this. This is my current ChatGPT interface, okay? Oh, no. Okay, so I'm gonna paste that here. So here's what I think will happen. We have this interface, and then in the settings, oh, it's actually a bad screenshot that I took, but whatever. I can deliver the point home. In the settings, we will have like one more place, which is like integrations, right? And then you will just be able to like add your API keys. Similar to how you can do that now in Zapier or Make, you just have your integrations / connections. and you can just add the API keys to whatever, like Google, just workspace, or API keys, or like sign in, or whatever the authentication is for that. So you will be able to add those inside ChatGPT. Things like, I don't know, maybe YouTube API, or Stripe, or I don't know, QuickBooks, or Webflow, or MailChimp, or whatever tools that you use. Right? You can add all of these API keys, and then the O3 will be able to just find these all the time the same way. So I think that's the future on what's going to happen So here, instead of like projects or under projects, maybe there will be like connections or tools, but it's probably going to be in the settings. So because you only need to connect them once, and then anytime you ask it to have like a new one, like a new thing to do, it's going to say, oh, I need the API key for that, dude. Tell me the API key. And it's going to be like, yeah, okay, here's the API key. Yeah, keep going. And that's how it will be able to constantly write the API requests. And the thing is like, writing these API requests is not that big of a deal. What's big of a deal is to figure out when to call which API. And that's why reasoning models are such a big step forward. Mevans says, are they not going to advance the 4.0 type models? Probably not, because those chatbot models are already really good. So if it's like they got to a point where they are good enough, first of all, and we also see that the reasoning models are actually pretty fast. Now with O1 responding in 5 to 10 seconds, that's enough to wait for something. Like that's now not like taking minutes like O1 Pro, which is actually like super slow. I barely use it, but I just use O1 all the time now. Because it's like, I can tolerate it thinking for 5 to 10 seconds. And then for fast use cases, like when I'm building a chatbot or something, I definitely need the 4.0 to be there and do it. All right, another question that I have in mind, and keep in mind that, let's see this one. The result is, out of 46 votes, do you think O3 will be available on the Plus plan? 57% of you say no, and only 43% say yes, probably yes with limitations. Interesting. Okay, I'm also gonna start a Q&A. I don't know. Ask me anything or what I do here. I'm not that big of a streamer here. And let's see if I can I still, everything disappeared. Oh no, the chat is still here, okay. Okay, let's start a poll. So, what do I want to ask? Okay, so yeah, so which ChatGPT subscription do you have? And first one is going to be free, plus, pro, team, and I cannot put in edu or enterprise, so it's only 4 options. So I'm gonna put in under, no, if you have those, don't send the poll. Let's see the Q&A. You guys send anything? András asks, Dave, are you Hungarian by any chance? Yes, I am. Boldog karácsonyt. Yeah. I actually had a call with a client today, and where I was making comments in one of the documents, and the guest username was written in Hungarian. She was like, "Oh, what's that word?" And I said, "Oh, it just means guest user." And she asked me to like, "Oh, say it." I was like, "Okay, vendég felhasználó. She was like, oh my God, that sounds really good. Yeah. Oh, okay, so what do I do with this select question? What happens if I select a question? Oh, it just highlights it like that. Oh, okay, with that effort, I can just read it out loud. So how far are these reasoning models from actual AGI? My intuition is that they are next word prediction models with built-in chain of thought prompting. Yes, that's exactly what they are, but as a human, you're also kind of that. As I'm speaking now, I'm also thinking about like, what's the next word that I'm gonna say? And I have a chain of thought that I want to follow. So I am also just predicting the next word based on everything that I learned, based on my personality, based on my emotions. And that's how things happen. Maybe we all are just language models. It's fascinating to me that how we humans, in general speaking, this is not about you, but it's like for all of us, we think that just because a language model, like some computer, can do and can say exactly what a person would say, but it's not, there is no emotion or no real thought behind it based on like neurons and sodium ions just going back and forth through some weird protein structures, because that's what a thought is really. So instead of sodium ions and action potentials going through the brain, it's electrons going through silicon, and now we think, oh, it's less than something. Oh, or maybe I totally misunderstood the question. Maybe you said that the AGI. Well, now as I read it again, yeah. So maybe you said that the AGI is actually the next word prediction model with built-in chain of thought prompting, because I think that's how what AGI will probably be. That what it needs to do is, I think the first AGI is gonna be an autonomous AI agent that can do almost anything that you ask it to do at the same level of how a human would do it, and probably at a fraction of a cost and a fraction of a time. That's the kind of criteria. AGI is like, the important thing is that it's better or at least equivalent to a human. So how far are these reasoning models from actual AGI? I think not so far. I am thinking now with these models released, let's say that we consider AGI to be an autonomous AI agent that can do tasks that a human would do at a level, any task that a human would do, like knowledge task, not like lifting blocks or making bread, at a level of how a human would do it. I think that's very close now. Yeah, I'm also thinking like 2 years or something. First versions of AGI, it's probably 2 years. It doesn't mean though it's the end of the word. So I just want to be clear about that. But what's missing here is like, once reasoning models have action capabilities and executive functions, then we are very close to AGI, because then the only question is how well do they perform compared to a human. Okay. Okay, so now this questions is not working because now I just lost the chat. So I'm gonna end the Q&A. Sorry guys. You can just ask in the chat. End Q&A. Okay. Let me just go back to the chat. Let's see what you guys have, what you guys say. Oh, it's a lot of chat. Google just released a thinking model an hour ago, guys. Gemini 2.0 Flash Thinking Experimental. Let's see. Gemini 2.0 Flash Thinking. Oh, it searches the ChatGPT again. Jesus. Yeah, so this is why I don't like the Chrome extension. This one, it was a day ago, not an hour ago. Google AI Studio. I haven't tried that. Okay, guys, give me a second to figure out how to set this up. Okay, I consent. No, I don't want to receive emails. Thank you. Okay. So here's what we see. This is the first time of me doing this in Google AI Studio, so we'll see. Preview, Gemini 2.0 Flash Experimental, Flash Thinking Experimental. All right, so let me move my head. So we can look at token count, temperature, safety settings. But civic integrity. Yeah, it's gonna be fine like this for me. Output length, can I increase this? No. Okay, so big limitation. Output length is 8,000, O1 is 100,000. All right, let's see. I'm gonna split my screen for in a second, and then we can just compare the two. What's a prompt that I should send to these two guys? Just gonna put myself in. No, where did I put myself? Like here, smaller. Okay, yesterday I did a very interesting thought experiment with GPT-01. It was a medical question, so let's rerun that. The question is, explain what happens to the oxygen molecules in humans. What how do they enter the body? How do they get metabolized? And how do they exit the body? Explain at a medical physiology exam level. Okay, this is the prompt. I'm gonna do a quick Q&A. Jeez, I forgot. It didn't copy it. Before I run the prompt, I want to see what you guys think. So, quick medical Q&A. Oh, let's see the poll. 35% on free plan, 53% on plus plan, 9% of you guys on pro plan, and 3% on the team plan. Very interesting. Team plan is kind of it's a bummer. Okay, thanks for sharing that. So, next poll. Oh, I'm not gonna, okay. Okay, just put it in the chat if you want to play around. Tell me, where does the oxygen that you breathe in, how does that exit your body? Tell me in the chat. And then meanwhile, I'm going to run the prompt because it's going to be at the end anyways. Okay, am I in the experimental? Yeah. Okay, feel free to tell me in the chat what you guys think. So yeah, so what happens is there's inhalation, it goes in the lungs, It even explains breathing. Then the conducting zone, respiratory zone, alveolar capillary. It explains how the partial pressure of oxygen is typically high, so it just goes into the pulmonary arteries where it's low. So oxygen diffuses, that's the correct answer. Then transfer in the bond, it binds to hemoglobin. Normal artery pressures, hemoglobin is oximetric. Yeah, that saturation is pretty accurate. Yes, it's dissolved in the plasma, so that's also correct. At the tissue level, the partial pressure of oxygen within the cells is lower. Yeah, so that's what drives it. Drives the oxygen going outside. Also, other things. Where did it mention the oxygen binding to hemoglobin? It didn't answer that. We'll see. Okay. Mitochondrial respiration. Cosmic cells knows their biology. So most people would say, oh, it like exits as CO2. But actually what happens is the carbohydrates get oxidized to carbon dioxide, and then oxygen is directly converted into water inside the mitochondria, and then it exits as water. Oh, it missed that. It says CO2 is transported back to the lungs. Exits as CO2. So that's incorrect. Actually, yesterday it got it correct. Okay, let's break down the journey. Entry to the body, ventilation. It didn't really talk about the pressures, so that's definitely a point for O1 here. Once air reaches the alveoli, the actual gas exchange process known as external respiration takes place. Alveolar structure and function. Okay. Oh, it explains the partial pressures, my bad. That's also good. It also explained the hemoglobin dissociation curve, which is plus 1.4 Gemini, actually. Yeah, it explains how that is changed. Like a lot of people in medical school just failed on not knowing this one. Gurzimar says, just when is O3 available? No, it's not. They said o3-mini is gonna be available late January next year, and then O3 a little bit later. Guys, in the chat, send me prompts to compare O1 and Gemini 2.0 Flash thinking. Okay, so it correctly gets that it forms water. But it also said that CO2 is removed. I'm really satisfied, by the way, with the Gemini response as well. Again, we are at the point where it's like for these, like this is not a hard problem. You just need to like tell what's going on. GAG says, guys, when they do all the jobs, I need to know. Well, a couple of years, dude. So you better learn how to master AI. I can keep you up to speed. If you guys are interested, just join the membership. We have a Prompt Master membership where I can teach you everything you need to know about AI and building automations for yourself, even agents. And as new things are coming like this, it's definitely a good place to be. So this is a slight plug, but I think when they do all the jobs, what you need to know is how to use it so it can do your job for you, so you don't have to work that much. Okay. Let's see. Yesterday where was the oxygen transport here? Oh, come on. Just load it, will you? Oh, that was 4.0 by mistake. Why does it not load the chat? There we go. Yeah, so when I asked it in two reasonings, it said what happens to oxygen molecules we breathe in and why. I fully explained like it's a physiology exam question. It didn't explain like what happens after. It only explained like serial utilization. And I said, okay, what happens to oxygen atoms after this? And then it correctly said that they get reduced to water. And then happens whatever happens to water in the body. So where do the oxygen atoms in CO2 come from? Do not primarily come from oxygen. They come from the carbohydrates, whatever carbon source that is. So that's the accurate answer. So I think Gemini also kind of missed that. It talked a lot about CO2. All right, so carbon dioxide. Let's see a follow-up. How does the O atom in O2 actually get into the CO2 molecule? Let's see if it can say, oh no, sorry, I made a mistake. It doesn't. That's an extremely insightful question. Thank you very much. See, empathizes with me. I feel so much better about myself. It highlights a common misconception about the direct transfer of oxygen atoms. The oxygen atoms in CO2 do not directly come from the O2 you breathe primarily. The carbon comes from the fuel. Oxygen atoms come primarily from water. What? The oxygen atoms that end up in the CO2 molecule primarily come from water. That's not even true. Okay, so this needs some work. For this sentence, it would probably fail the exam. Okay, so electron transport chain, yes. Formation of water. Okay, so it kind of gets it, but I mean, this analogy is a little bit weird. The carbon in the exhaust, like a burning fuel, comes from the gasoline itself. The carbon, yes. The oxygen in the exhaust doesn't come directly from the air entering the engine. Yes, it does. There's an air intake in each engine. Instead, the air containing O2 is used to facilitate the combustion process. Yeah, the combustion process is like what's needed to burn the fuel. And oxygen atoms from the fuel itself and potential. No, dude. Okay, so again, I think it needs to work a little bit. Okay, solve this riddle. Okay. I cannot just quickly copy paste, so I will have to just, oh, I can, hold on. What is the next number in the sequence? Okay, thank you. I'll just start a new chat answering this. And then after that, we gotta wrap up the session, unfortunately. I'd love to keep streaming, but for those of you watching who are new to this channel, just make sure you subscribe. Oh my God, I can say these things like what YouTubers say. Just make sure you subscribe to the channel, like this video, hit the bell icon. And yeah, so the main thing is, just quick introduction. I am an AI educator, so I teach people how to use AI for themselves, for their work, and how to build automations that they can use for themselves or they can sell to clients. So if you are interested in that, in the in the description under this video, you can find a bunch of links like a free newsletter that I have. You can also check out another like ChatGPT crash course that I created, and you can also join the membership if you want. So feel free to do that. Let's solve this riddle. And thank you very much for your support. I forgot that. Thank you very much for your support. Thank you very much for being here. Did I start a new chat here? Oh, clear chat. This cannot be undone. Oh my God. Okay, Cosmic Cells, can you tell me? Okay, answer. 15, they are humans who sent the Arecibo Mercury message to Hercules. What? The labors of Hercules. Okay, so it got the Hercules thing. Okay, so O1 nails it. This one didn't. And who are they? They are gods. They are human. No, yeah. So the correct answer here, remember, in sequence is 15, and they are the human scientists who crafted and sent the Arecibo message. Here's where my illiteracy shines through, that I have absolutely no idea what that is. I was a really science-oriented guy growing up. Hydrogen, okay, so maybe I should have known this. Phosphorus, Jesus. Nice. I like that. I would have never figured this out. Owen beat me for sure. Like even Gemini gave it a try. I would say I have no clue. Okay, I'm gonna say try again. Yes, maybe give it a hint. Try again. The numbers are not about the labors. Maybe that helps. Oh, here we can see the reasoning token. Oh, wow, this is fascinating. Okay, so what were the numbers? Numerical system. Oh, so, oh my God, my dumbass. I thought this was like from Greek mythology. But it's actually astronomy. Okay. What if I told you this is related to astronomy? No, it doesn't get it. But it could be because it could already know the riddle. because it didn't quite figure out through the thinking or reasoning. It's very interesting. So I highly recommend you guys to give Gemini 2.0 Flash Thinking Experimental a try, especially now that it seems like it's free. Because you can see the thoughts, which you cannot see in ChatGPT. Like this is only, it says these things, but it's just a summary of the thoughts. And this seems like a more open and transparent reasoning. So I highly encourage you guys to give that a try. See what happens. All right, everybody. I'm gonna bounce. Thanks a lot for all of you for being here in these last, well, it was 12 business days, so more than 2 weeks, and tuning into the stream, enjoying these announcements with me, or feeling underwhelmed by them. This was a thrill. So thanks all of you for being here, and I'm gonna keep you guys updated. I'm gonna be publishing more videos on the YouTube channel starting next year. I'm taking the rest of the year off to fully recharge so I can take on 2025 head first with a bang. So those are my plans for the future. And yeah, thanks a lot for all of you for coming. This was crazy, a wild ride with OpenAI. If anyone from OpenAI is watching this, thank you guys for putting out all this amazing stuff and doing it on a regular live stream schedule, so we could also enjoy it together and lose our shit with O3 and so on, and Sora and O1. So thank you OpenAI for doing this. And again, thank you guys for just being here in the chat and just engaging with me in these interactions. If you want to see more about AI and how you can use it for your work, feel free to subscribe to the channel. And yeah, that's it for me pretty much. Thanks a lot for all of you for being here. Goodbye. Merry Christmas to all of you and Happy New Year. And I'll see you guys in 2025. So take care, everybody. Goodbye.